for Grandpa's Lab. Brought to you by the Science Academy and the Newton Institute of Technology. Learn how to make your own lab.
Hello, young scientist, and welcome. It's good to be with you. Today we're going to be discovering how to make our own lab and how to build this lab station. If you don't know how, just keep watching. Welcome you to our very first episode of Grandpa's Lab Online. I'm looking forward to the times that we can spend together discovering the wonderful world that the Creator God has designed for us to enjoy. I was very young when I became curious about the world around me, and I wanted to know more about the things that were made and why they were made. Then I discovered science. Science is the search for truth. Science comes from a Latin word that means knowledge. So, the search for true knowledge. I noticed that if I learned what was true about what I studied, I could make important discoveries. We're going to learn how to make our own lab, but our experiment will be about this red cabbage, and we can test the cabbage to learn more about it in the laboratory. As a very young scientist, about 8 years old, I wanted to make a laboratory. I didn't even know really what a laboratory was all about, but I saw some pictures in a book. A laboratory is a place for scientists to collect things to study and to make and to test observations that they see. I decided that I needed a place to search for truth, a place to learn, to invent, and to experiment. Today I want to give you some suggestions for making a laboratory at your house or in your classroom. Think about how you would make a laboratory at your house or in your classroom. What would you do first? What kinds of equipment and supplies would you gather together? First, you need a place. And here I'm standing in my laboratory. I'm going to take you on a tour of Grandpa's lab. Here's the purple cabbage, or the red cabbage boiling. There's a little jack stand. We can adjust the height. There's a condenser. And it's connected to a boiling flask. And we have cooling water tubes coming down. There's the sink. There's a test tube rack and some more bottles. There's a big boiling flask. And there's a funnel and a tube going down. We grind things up with a mortar and pestle. Then there are the chemicals and the gauges and equipment. And there's a picture of George Washington Carver. There's an oscilloscope. There's a big microscope. Lots of books, old books and new books. Different kinds of bottles and glass to help me in the lab. This is Galileo's thermometer, and the bulb that's closest to the middle, both of those bulbs, is usually what temperature it is. Wow, it's about 80 degrees in here. This is my first microscope that my mom and dad bought me. Of course, we have some skeletons around. There's a Diplodocus. There's an alligator skull. Oh, that's a bear skull from the Midwest United States. There's a light bulb. Reminds me of Tom Edison. There's an old microscope. Look at that. Oops. I even have a rattlesnake. Oh, that's just a toy one. Got some teeth that were given to us by one of my students. Ah, some scorpions. a gift from our missionaries in West Africa. Wow, look at those. That's a big one. More books. Oh, and here's some butterflies. Can you identify that butterfly? It's a monarch. What kind of a bug is this? It's a leaf bug. Wow, look at that. Then here's a blue morpho. Isn't it a beauty? Look at that. The blues are so shiny. Be sure to ask your parents or teachers to help you decide on that place. It needs to be a place where you can think and test things and observe things. Your place could be a garage, a basement, or a corner of the room. Your place could start by just having a special box. A box could be a container like this, a shoe box like this, or a small cardboard box. When I decided that I wanted to make my first laboratory, my family and I lived in North Carolina. There was a garage in the back of our house, and my parents gave me permission to make a laboratory there. I enjoyed looking at pictures of laboratories, and I'm going to show you a picture of a laboratory. Shows two young men, and they're working with some bottles, and there's a flask there called a boiling flask, and it was from this book that I saw some very interesting photographs about rocks and minerals and also science laboratories. It's always good to have books in your laboratory. Also, it's good to keep a lab manual or a log book. And in this book, I write notes about things that I want to continue to learn about. This book doesn't have to be very large. It could be a 3-ring binder with notebook paper, or it could be a simple sheet of paper if you don't have a book. You do not really have to have special equipment or supplies in your lab. I'm going to give you some ideas about things that you can use that you might really already have at home. If you do not have them, you might be able to find them at stores near your home. And you can be very creative when you plan your laboratory. That's part of the fun of it. I'll give you some specific ideas about lab supplies and equipment and a little personal laboratory that you can make by yourself. I want to tell you about a very famous scientist who needed to be creative in planning his laboratory. His name was George Washington Carver. Oh, you've probably already heard about him, haven't you? Dr. Carver is one of the most creative scientists that ever lived. He was a great teacher and inventor. He was a botanist, a chemist, and an artist. And one of the most important things about Dr. Carver was that he was always trusting in God to give him wisdom and knowledge to make his discovery. Went up to his laboratory, and there God gave him 300 things that a peanut could be used for. Isn't that amazing? A bag full of peanuts. You know, after he learned 300 ways to use the peanut, boll weevil had started eating the cotton crops up that they were so famous for. And over time, these bugs destroyed the crops. But Dr. Carver was working on the uses of the peanut, and he encouraged farmers to plant these peanuts instead of cotton. As a result, Alabama became one of the most wealthy farming states in the United States in his day. Dr. Carver taught for 47 years at the Tuskegee Institute in Alabama. It was important for Dr. Carver to have a laboratory for studying and teaching, but many years ago it was very expensive to get equipment and supplies for the lab. Let me show you a picture of Dr. Carver in one of his laboratories. Before I give you a list of some of these things for your lab, I want to remind you about one important thing, and that is safety in the laboratory. Safety in the laboratory means that you take care of yourself and you protect yourself against accidents. I'd like to share some of the safety rules that I follow in the lab, and hopefully you can follow the same rules. Number one, always ask an adult before you do an experiment. Explain that experiment to them and what you're going to do. Number two, always think before you do an experiment. Always think before you act. That way you'll be safer. Number three, always write down what you will do or test. Number four, always ask yourself, is this dangerous to me or others? Always stop if the answer is yes or maybe, and get someone to help you. Number six, always have an assistant working with you. That could be a mom and dad, an aunt or uncle, or a big sister or big brother. Someone that will seriously help you. Always wear eye and body protection. Now we're going to construct our own laboratory, and I'll show you how step by step that you can use different kinds of supplies or materials in doing that. This is a lot of fun, and then we will do an experiment. Okay, let's get started. Making your own laboratory can be a lot of fun. All you need is some nuts and bolts and some pegboard, but you can also use a simple cardboard box, and I'll show you how that you could do that. You can take a small box like this and push a pencil through it that you would find around the house, might come in the mail. But all you need is a piece of number 12 wire. It can be any color. Solid wire is usually best for making clamps in the laboratory. What we'll do with our box is just take a pencil and be very careful as you're doing this. And you can punch a hole right in the top of the box. Just kind of rotate the pencil and punch a hole there, and then punch a hole right here. This is on the side of the box. I think I said top. It really doesn't matter though. You could even have it coming off the front where you keep your chemicals or supplies. But we'll put it right here for today. Now, some of us might find small bottles in our home that we can wrap our clamp around, and this is the neck of the bottle right here under the little threads where the cap would go, and we're just going to wind this wire around the bottle to hold it nice and secure like that. And then we will take this wire, and you see the hole there and the hole there. What we'll do is run the wire into the first hole and look inside the box and just pull that wire all the way through and put it in the other hole on the inside of the box. You see, here's the other end of the wire. So we have one wire coming out of this side and one wire coming out there holding our bottle. And then I'm just going to take this wire and pull it back over and flatten it out so that this is nice and strong now, and that will support our experiment bottle. So then we can close up the box if we want to. At a home improvement store, you can pick up a piece of pegboard like this. This is 12 inches by 12 inches. This is about 6 inches by 12 inches. And they can cut that for you right there in many of the stores that have what they call panel saws. Then you need a few 6 to 8 inch threaded bolts. These are called bolts, and I have several of these. And these are 1/4 inch threaded bolts, and there's a little what we call nut that goes on the threads, and you can see me threading that over the bolt. Okay, well let's put this together, we're going to make a stand that will hold this board up and also support a larger threaded rod. Look at this one. This is 12 inches long. And as you can see, I've threaded a nut right in the middle of this threaded rod, 12 inches long, and it's 1/4 inch in diameter. That means how wide that bolt is. Then there's another little nut that's real close to the end, and we will put it on this big board. Right here. I stuck that in this big board, 1, 2, 3, 4, 5, 6 holes away from the edge, this far. 1, 2, 3, 4, 5 holes into that edge. I'm going to turn this over, and you can see the bolt sticking out here, and I'm going to put a nut on it to keep it from coming off the board and wobbling it. I'm going to take this 6-inch bolt, and I'm going to put it through the hole that's almost in the corner of the pegboard. And then I'll put a nut over that and tighten it down. And so I'm going to hold that steady and just take my finger and roll that nut all the way down to the bottom. Here we go, almost there. And we'll tighten that up. And we'll do the same over here with the same size bolt. You can see that it's almost at the corner, the first hole there. And so then I'll press down. It's always good to put a piece of cardboard or something, or a mat, placemat under your bolt so you won't scratch up your mom and dad's table. It's good to do this outside on the deck or in the garage or just on a surface that you don't have to worry about scratching. There we have it. We have 1, 2, and then 3, our real long post right here. Okay, now I'm going to put a nut on this bolt and a nut on this bolt over here. Let me turn this where you can see it. And here we go. We're going to roll this nut down just about 1.25 inches or 1 inch or so on each side, and do it over here as well. You can adjust these so that they're about the same, and then put a nut on the center post. And then what we'll do is put our little piece of pegboard on, and you can adjust it to fit however you would like. We want it to be level, so we're going to adjust these nuts under the board. So that this top platform will be level. There we go. Now I'm going to put a nut over this real long 12-inch post. Remember, that was almost in the center of the board. And we're just going to rotate this nut all the way down to the center right here. So now this is being supported by 3 bolts. We're going to put a nut on the top of these shorter 6-inch bolts to support this platform. Now, how do we make a stand to hold a bottle, or what we call a support stand and clamp? What we want to do is take a piece number 12, and you can go to a home improvement store and they can cut off 24 inches for you, or 48 inches if you want to put two. Then just take this and wind it around your post. Make a coil. In electromagnetism, we make coils and we wind wire like this. But this coil will hold tight to your post and support your glassware. Just knocked it over. Okay. Now, how do we support our bottle so that it will stand up right, and even if we tipped our table a little bit, it would support it? Well, we make a coil. I'll turn this around. We'll make a coil around the bottle's neck. You see the neck of the bottle there. When I say neck, I'm referring to this part of the bottle. There we go. So now let's take this bottle, put it right here, and we'll make a coil around the neck. And you can use different size bottles. I always like to have my bottles nice and secure on the table. So there it is. And here we can have a stopper to close our bottle up, but if we tilt it, it won't knock over. Isn't that great? It's something you can do with your laboratory. There are all kinds of bottles you can put on the stand. Small bottles, large bottles, even real large bottles. And I'll show you a little later about all the different kinds of supplies that you can use in your lab. But old bottles that your parents are throwing away might be good to use in your laboratory, but ask them first. Now, on the very tip of the post, it's good to have a cork or a rubber stopper, and I'm going to drill a hole in this stopper. There we go. And that stopper will go on the top of the post right here. You see, this is where our coil is. This is the top of the 12-inch post. And we want to put this stopper over the tip of the post so we won't stick that post into our skin or our eye when we're working in our lab. And so this is what it looks like. Okay, well there we have the beginnings of a workstation. Spent some time making some of this purple cabbage juice, and it's been soaking in hot water from the faucet for about 15, 20 minutes now. And I think it's ready to go. I'm going to take an eyedropper or a pipette and soak up some of this purple cabbage juice, red cabbage juice, whatever you would like to call it. We'll just call it our purple indicator. And there we go. It's in our tube or bottle. Okay. And now we're going to test some vinegar, and let's pull out our little vinegar bottle, and remember, vinegar is an acid, so if this vinegar is added to a purple indicator, it should change color, shouldn't it? Let's see what happens. It does change color. Look at that bright red. Can you see it? It's different, isn't it, from the purple? You can compare, if we pour some of the purple into one of our little cups, these two colors are different. Purple and red. The red has the vinegar in it. And remember, vinegar is acetic acid. Now what will happen if we add baking soda We're just going to try powder baking soda. Cap off our vinegar. Here's our baking soda, and get a little spoon. Remember, we can get these spoons for about $1 a pack at a discount store. Now, baking soda is the opposite of an acid. It is called a base. And we're just going to pour a little bit of the powder into the purple indicator and see what happens. Remember, the acid turned the vinegar, turned the purple indicator to a red. What happens when we mix baking soda? Wow, look at that. What a nice green color. Do you see that? It turned it green. So let's make a comparison. Green and red. The red forms when you put an acid in the purple indicator. The green forms when you put a base or baking soda in the indicator. Why don't you try that at home? That's a nice, safe way to discover the differences in acids and bases. We used warm water to make up our cabbage juice or our purple indicator, and we used a popsicle stick to stir it. And that is an easy way to make up your indicator. And here we have a purple solution. You can tell it's really dark now. And we're going to need some vinegar. This could be household vinegar. This is about a 4% strength. Vinegar is acetic acid, and it's the opposite of baking soda. And the baking soda is white, and it's a base. This acid will kind of have a tingling effect. Tastes real sour. For example, eating a pickle. It's real sour. Okay, and then we'll need a few bottles. Collecting bottles is important if you're building a laboratory. And then some spoons. These could be purchased for $1 at a discount store. So we'll pull a spoon out of there. And some labels. You can use a piece of white paper and Scotch tape, or you can just take a sheet of labels like this and cut them so that they fit on your bottle. Now I'm going to take, this is a little salt shaker bottle, and I've already put a label on this for our vinegar, and I've labeled it vinegar 4%. And you can put a piece of tape over that to make sure it stays on the bottle. These bottles have a top that come with them, and they have holes in them. But what you can do is take a piece of paper or thick poster board and cut a little disc out or circle and put that inside like you see there. Even though it has holes in it, this would be good for powders. Now, what about for liquids? I would take a piece of wax paper and put it inside that lid. Like this. And then when you close it down, that will seal off that. Or in some cases, you might have a bottle that has a black stopper, and that's good for sealing off the bottle. These black stoppers can be purchased at hardware stores, and you'll have to fit them. Some bottles, the Old Spice bottles, come with a little stopper like that. Okay, let's pour our vinegar in our chemical bottle. And so we'll just open up our vinegar and pour it right in. You don't have to have a whole lot, just enough for experiments, and put the rest back in the pantry. Ask your mom or dad for permission to do that. And now baking soda. What we'll do is take our label off of our sheet of labels. I cut these into little 1/2-inch strips. And we'll stick this right on the front of the bottle, just like we did our vinegar. And so we have a little bottle that needs a little gasket in there, so we'll put paper in and just a little piece of wax paper to keep it sealed, just like we did the vinegar. Although this isn't wet, it still needs to be sealed up. Okay, we'll close this down. Stick that label on nice and tight. And again, you might put a piece of Scotch tape over it. Okay, let's take some baking soda out of the box, and we're going to put it in the bottle. A little bit more. And you don't have to fill it all the way up, just enough to do your experiment with. And very good. Then we'll cap that off. Now on your lab table, after you've put the legs on it so that it can stand up on a table, you can put your bottles down here below like that, or you can put them up top when you're experimenting below, and move your test tube over to the side or wherever you would like to do the experiment. Now I'm going to put a little bit of the purple cabbage juice in the test tube, and I'll use a pipette and suck up some of this juice, and I'll put that right in the test tube, just like that. And then I want to see what will happen now if I add an acid to this. Remember, acetic acid is vinegar. So we'll open up our vinegar bottle. And I'm going to take the pipette and suck some vinegar up in it. And I'm going to put this in here, and look, it turns a bright red. I'll shine a little light through that so that you can see that the color really is a bright red. Okay, now what will happen if we add some baking soda to some water? Let's take our spoon And put some in our beaker. 2 spoonfuls. And we'll cap this back off. Put some water in there. And that's good. Now we're going to mix this up and make a milky solution. And then what happens when we add some of our purple indicator with anthocyanin in it to our milky baking soda solution? What color does it turn? You're right, green. Green and red, these are the 2 colors that the anthocyanin will turn. And sometimes, depending on how acidic or how much acid is in it, it will be a different color than the red. It could be an orange color. I've been observing. And now, write that down in your logbook. You'll take your logbook and pen and write down the results of your experiment. You can write down the word vinegar. Plus red cabbage juice equals a bright red color. And then you can do the same for baking soda. Baking soda and water plus the purple indicator will turn green. I've enjoyed being with you today, and thank you for joining me for this episode. And until we meet again, please join me at scienceacademysite.com or grandpaslab.net. And I want to encourage you to pray for wisdom before you start your experiments, just like George Washington Carver did. And God will give it to you. And until we meet again, have a good day.
Get on board and join the Science Club.